In this session, I will present how to add support for different meta-modeling technologies in Eclipse Epsilon. And to be able to do this, you will have to implement a new EMC driver for Eclipse Epsilon. I will present some of the technical aspects related to the implementation of EMC drivers, and I will also do some hands-on exercises. This is the architecture of Eclipse Epsilon. On the top side, we have the various Epsilon languages, such as ETL, which stands for the Epsilon Transformation Language, and it is used for model-to-model transformations, or ECL, which is used for model comparisons, and EGL, which is used for code generation, and so on and so forth. And all of these Epsilon languages are based on the Epsilon Object Language, which is also called EOL. Together, all of these Epsilon languages, including EOL, are able to access models and interact with models conforming to various meta-modeling technologies. And this is done via the Epsilon Model Connectivity layer, which is also called the EMC layer. On the bottom side, we have some examples of the meta-modeling technologies that are currently supported in Eclipse Epsilon. Now, the Epsilon Model Connectivity layer provides abstraction facilities over concrete modeling technologies. You could think of it as a set of services that you have to implement such that you add support for a specific modeling technology in Eclipse Epsilon. And this enables Epsilon programs and languages to interact with models conforming to the new meta-modeling technology that you have implemented in Eclipse Epsilon. Now, the way the EMC layer has been implemented in Eclipse Epsilon is that it makes minimal assumptions about the structure and organization of the underlying modeling technology. And this has the advantage that the EMC layer is more resistant to future changes in the implementation of modeling technologies. And in this way, it can embrace new technologies without changes. From a technical point of view, to be able to do this, it had to intentionally refrain from defining classes for concepts such as model element, type, and metamodel. And of course, this has the disadvantage that you have to implement them yourself. You have to implement these classes yourself. So there is more effort into this. But again, it has the advantage that it can embrace new technologies without modifying the source code of the EMC layer. For the implementation of EMC drivers, two Eclipse plugins are required. The first plugin is for the implementation of the driver's Eclipse-based development tools. And the second plugin is for the implementation of the driver itself that contains the business logic of the driver. Now, if you would like to develop an EMC driver and push it to the repository of Eclipse Epsilon, you would have to use these naming conventions, where XX stands for the meta-modeling technology used, for example, XML, CSV. Now, I am going to continue by presenting the first part, the first plugin that must be implemented, which is the Eclipse-based development tools. Now, the goal of this is to provide a dialog to configure models conforming to the new meta-modeling technology that you would like to add support for. The dialog looks like this, and the purpose of this dialog is to select a model from your workspace, give a name to your model, maybe an alias, and also to provide some properties related to your model. For example, read on load, store on disposal. These are built-in properties, but you could add your own properties. For the implementation of the configuration dialog, you would have to implement a class for the configuration dialog, which looks pretty standard most of the times, and it contains about 100 lines of code. Here we have some examples of configuration dialogs that were used for the CSV driver and the plain XML driver. As this presentation will be made publicly available, you will be able to click on these links and see the classes. Now I will just show the class that was used for the configuration dialog for the CSV driver. And in this case, it extends the class abstract cached model configuration dialog. There are some fields in this class and a few methods that you would have to implement. Most of the times these classes look more or less the same. You would just have to modify some titles, some names to customize the implementation, and that would be about it. But depending on your scenario, this can get quite complex. Now, to implement the configuration dialog, minimal SWT knowledge is required, and the dialog class typically extends one of the following classes: the abstract cached model configuration dialog, which is the class I just presented previously, or abstract model configuration dialog. I recommend extending the first class because it adds support for caching, and the second class is the superclass of the first class. Now, this is the configuration dialog that was used for the YAML driver, and in this case, it extends the abstract cached model configuration dialog. And if I open this class, you could see that it extends abstract model configuration dialog. And each of these classes adds new features to the dialog. I will show some more about this later on. Here we have the declaration of the configuration dialog of the YAML driver, and this class extends the class abstract cached model configuration dialog. In here we have some fields and some of the methods that you would have to implement. The first method is called getModelName, and in this case it returns YAML document. The return value from this method will be actually displayed in the title of the configuration dialog as shown in here. Also, you would have to implement another method called getModelType, and in this case it returns YAML because we are working with YAML based models. And for example, if you would be working with EMF based models, you would return EMF. Another method that you would have to implement is called createGroups. And this method calls other methods, and each method that is called would be responsible for creating a group or a part from this dialog. The first method that is called is from the superclass, from the class abstract cached model configuration dialog, and in this case it would generate this part from the dialog, the blue part. So you would not have to implement this by yourself. This is built in and this comes from the superclass. Then the second method, createFilesGroup. This class would be implemented by yourself, and this is responsible for generating some fields related to files, for browsing the workspace, for selecting a model element, and so on and so forth. Then the third method is actually inherited from the superclass, so you would not have to implement this by yourself. And this creates some fields that are related to some properties of the model, like reading the model when it is loaded or storing the model on disposal. Now, I will actually show some code about this. This is the configuration dialog of the YAML driver. And if I go into this method, you could see that this method is actually implemented in the superclass in the abstract cached model configuration dialog. And this method also calls the createGroups method from its superclass, which comes from abstract model configuration dialog. And this method calls createNameAliasGroup. And this method actually creates the beginning from the dialog, which contains the fields for the identification, for the name of the model, for the alias of the model. Now I am going back to the class abstract cached model configuration dialog. And in this class, in the method createGroups, it calls the createGroups method from the superclass, which I've already shown. And it also calls the createPerformanceGroup method, which is responsible for creating the fields related to the caching of model elements. Remember, there were some properties named cache model elements to improve execution time, and trade save cache, and so on and so forth. Now, in the configuration dialog that you would have to implement yourself, remember that there was a third method called create load store options group. This comes from the superclasses. This is inherited, so you would not have to implement this by yourself. It creates some fields related to load store options, whether you want to read unload the model or store and disposal the model. Remember, this is this part from the dialog. So this comes by default from the superclass. Also, this blue part comes by default from the superclasses. The first part with identification name and aliases comes from the class abstract model configuration dialog, which is the superclass of this class. And the part with performance, cache model elements to improve execution time, and thread save cache comes from this class, abstract cache model configuration dialog. This is the method that I presented earlier, create name alias group. And this is responsible for creating this blue part from the dialog. You could see in here that we call a method called create group container, which will create this group container, and it has the name identification. Then it creates a label with the text name, and then it creates a text box, which is side by side with the label name. Then it creates a label with the text aliases, and then it creates a new text box for the aliases. Then here we have the create performance group method, which I presented earlier. And this is in the class abstract cached model configuration dialog, so in the superclass. You could see in here that we create a group container called performance, and this comes from here. Then it creates a button of type SWT check, so this is a checkbox, which has the text cache model elements to improve execution time. And it is selected by default because the method setSelection was called with the parameter true. Then it creates a new button of type SWT check, so this is a checkbox, which is not selected because we called setSelection false. And it has the text thread save cache. Now for this part, this comes from the method create load store options group, which is implemented in the superclass abstract model configuration dialog. In here, it creates a group container called load store options. Then it creates a label with the text read unload, which comes from here. Then it creates a button of type SWT check, so this is a checkbox, which is displayed side by side with the label. And in this case, it is selected by default because it called the method setSelection true. Then it creates a new label, which has the text store and disposal, and a new button, which is displayed side by side. And here we have the method create files group, which is responsible for creating this blue part from the dialog. This would be implemented by yourself, so this is not built in. In here, it creates a group container called files URIs. Then it creates a button of type checkbox. It sets its text to workspace file, which comes from here. Then it creates a label with the text file, which is this one. Then it creates a text box, which is displayed side by side with the label. So this is the text box. And then it creates a button with the text browse workspace, and so on and so forth. This is the method toggle enable fields, and if you remember, this method has been called in a previous method, in the create groups method in the last line. And this method, toggle enable fields, is used for setting the various fields of the dialog to either as enabled or disabled. In here, with the orange arrow, we show that file text has been set to enable, and this text box, of course, is enabled, and the URI text box has been set as disabled. Also, the method setText is often used for setting the text of a text box. In this case, the text is set to an empty string for the URI text box. Another method that you have to implement, and this is quite an important method, is the store properties method. Now, in a dialog, the user would enter various properties. For example, the name of the model, the alias of the model, various properties related to the model such as read-onload or store and disposal. These are Boolean properties. And you would put all of these properties into a map-like structure. And that map-like structure is, in this case, a string properties object in which you put as a key the name of the property, for example, type, name, alias, and so on and so forth, and the value of the property. Now, why would you do this? You would do this because you would take from the dialog the various properties of the model entered by the user, and then you would use those properties into your driver. Now, some of the properties that are put into this map-like structure are populated by default, meaning that, to give an example, the name property, the license property, all of this from the performance group properties are created in the superclasses. Remember that you have this behavior built in by using the methods from the superclasses. Also, read, onload, and store and disposal, they come from the superclasses. These parts from the dialog have been populated using some methods from the superclasses. Therefore, the superclasses did this part themselves. They populated this map using these built-in properties. So you don't have to put these properties that are already built in. You don't have to put them into the map-like structure, but you do have to put all the properties that have been created by yourself in the configuration dialog class. To show this, I will show some code. So this is the configuration dialog class of the YAML driver. We have a method called stored properties. And in this method, we just put the properties that have been added in this class, in this custom class. But we don't put the various properties that have been added by the superclasses. Because right now, if I go to the superclass, and I go to the method store properties, you could see that this class already populates the map-like structure with some properties. For example, in this case, since we are in abstract cached model configuration dialog, it adds some properties related to caching. And if I go to the superclass of this class, which is abstract model configuration dialog, this class would also add some properties that have been created in here. For example, the name of the model, the license, and so on and so forth. So again, the idea is that you only have to populate that map with the properties that you have added yourself in the configuration dialog. All the properties that are coming from the superclasses have been already added to the map-like structure. And depending on its values, in your driver, you would fetch the values from this map and you would execute different business logic depending on the values of these properties. For example, if the value read onload is set to true, you would execute a different kind of logic, but if the value is false, maybe you would do something else. Or if store and disposal is set to true, you would do something, and if it's false, you would do something else. And that's the idea. In this map, you put all the properties from the dialog, and then in the driver itself, you would fetch the values from the map and execute different business logic depending on the values. I am going to do a few exercises related to the customization of configuration dialogs. First, I will modify the model name, and then I will add a new group in the dialog, which contains a new text field or a text box and a checkbox. This is the YAML driver, the configuration dialog of the YAML driver. And to modify the model name, you would just have to return a different string here. I would just call it YAML custom document. And to create a new group, you would have to go in the create groups method. And in here, you would have to call a new method that would create the new group that you would like to create. In this case, I will call the method create YAML group. And this is the method. I already have the code prepared to not waste time. And this method makes use of two variables, which I will declare now. It makes use of a text and a button. Text is for a text box and button is for creating a new button. Now this group is called YAML and it creates a new button, and the button has the text allow duplicates. Then it creates a new label, and the label has the text ID field. Then it creates a new text or a text box. And whenever one would hover over the text box, this tooltip would be displayed. Now, to see these changes, I have to launch a new Eclipse configuration, an Eclipse application configuration. I already have it prepared. It has set all the defaults in here, so you don't have to modify anything. I will just run it. Now, in this new Eclipse instance, you would have to go to the run configurations. In this case, I'm using an EOL configuration. And in the models tab, you would click on add and select the new model type. And in this case, it's YAML document. And as you can see in here, instead of YAML document, right now we have YAML custom document, as we have set in here, get model name, YAML custom document. So this sets these fields from the title. And also we have a new group in here called YAML. Remember, this comes from here. Create a group container called YAML. And then we have a button of type checkbox with the text allow duplicates. And this comes from here. It's a button of type checkbox with the text allow duplicates. Then we have a label called ID field and a text box. And this comes from here. We have a label with a text ID field, and we have a text box. And really, that's about it. And I'm going to go back to the presentation. For the implementation of an EMC driver, you have to implement two plugins. Until now, I've presented how to implement the driver's Eclipse-based development tools. But this is not really the important part of this presentation. In here, we just presented how to create a configuration dialog in which you set a bunch of properties, and you would fetch those properties in the EMC driver itself and execute different business logic depending on the values of those properties. But really, the important part of this presentation is on the implementation of the EMC driver itself. So again, to show some code, Until now, I presented some technical aspects related to the implementation of the Eclipse-based development tools plugin, in which you have a configuration dialog. And now I will continue with the implementation of the plugin for the EMC driver itself, in which you have some classes that you have to implement and some methods that you have to implement. So for the implementation of the EMC driver itself, 3 classes are required. You have to implement a class for defining the model, and this class has to implement the interface iModel. Also, you need a property getter class for the model, and this class will be used for retrieving various properties from the model. And for implementing it, you have to use the interface iPropertyGetter, and you also need a property setter class for the model, in which you set various properties of the model. This class has to implement the interface iPropertySetter. These are links, and you can go to these classes to see how these interfaces look like. Now, to show some code, this is the EMC driver for the YAML driver, and you need a class for the model. In this case, the class is called YAML model, and in here we have many methods. Many of these methods always have to be implemented. You have to override them. For example, dispose model, delete element in model, load model, and so on and so forth. You also need a property getter class, and in this case it's called YAML property getter, and you also need a YAML property setter class, and we just have one method in here that has to be implemented. Now you have to implement a class that implements the interface iModel, and you would have to implement these methods yourself: load, store, get all of kind, is kind of, get all of type, and so on and so forth. And you would also need to implement 2 classes, one which implements iPropertySetter and one which implements iPropertyGetter, and both of these classes only have to implement one method that is called invoke. For defining the class of the model, you could either extend or implement one of the following. You have to implement the iModel interface in one way or another. Now, if you choose to extend the class model or cached model, they already implement the interface iModel. So the hardest way to do this is by implementing yourself the entire interface of iModel. And in this case, you would have to implement all of the methods from the interface. But if you choose to extend one of these classes like model or cached model, there is less work involved because these classes already implement some of the methods from the iModel interface. And the recommended approach is to extend the cached model class because it adds support for caching model elements. Now, if you choose to extend the cached model class, the first thing that you have to do is to identify what is a model element in your modeling language, because the class has to be parameterized using the identified model element type. Now, here we have some examples. For XML, a model element could be an XML node or an XML element, and in that case, you would have to parameterize the cached model class with the element class, because element would represent a model element in XML. Now, when using CSV, you must identify what a model element is in a CSV. And a model element could be a row in a CSV. And in that case, you could represent a row as a map. And in this case, this is a real example in which the model element is of type map string object, and The string is used for representing the column or the column name, and the object is the actual value located in a specific row at the specific column. Now, for YAML, a model element could be an entry, so a key value pair. And the methods that you will be implementing from the iModel interface, most of them must also be parameterized using the identified model element type. Throughout the code, you will be using that model element type. For example, if you are retrieving model elements from a model, of course, you must set the return type to the model element. And if you would parameterize your class with map string object, then most of your methods would also be parameterized using the same type. Now, to show some code, here we have the CSV model. So this is the model class used for the CSV driver, and it extends cached model being parameterized with map string and object. You will see that this type is often used throughout the class. Many of the methods are also parameterized with the same type because this is with the type of model element that you're working with. And also this is the model class for the XML driver, and in this case the cached model class is parameterized using the element type. And also many of the methods are also parameterized using the element type. Now here are some examples for defining the model for the CSV driver, for the plain XML driver, for the YAML driver. You could click on these links and they will redirect you to some of the examples that I've already shown just now. The next thing that you have to do is to hook the new model to Epsilon. So after you define the class of the model, the next step is to inform Epsilon that there is a new type of model available. And to do this, you will have to define various fields to define the name of the model, the class of the model, the class of the configuration dialog, and an icon for the launch configuration. You would do this into the first Eclipse plugin that I presented, which is used for the Eclipse-based development tools. You would go into that plugin, into the manifest file in the extension tab, and you would have to use this extension point. When you go into the manifest file in the extension tab, it will look like this, and you will have to define these fields: the class of the model, the label, which comes from this method getModelName that I presented earlier. This is a method that is implemented in the class of the configuration dialog. And also you have to specify the type, and this comes from the method getModelType. And again, this has been implemented in the class of the configuration dialog. Then you would have to specify the icon of the new model type and the class of the configuration dialog. Now these are the two Eclipse plugins. This is the plugin for the Eclipse-based development tools that I presented in the beginning. Then you would have to go into the manifest file in the extensions tab. You would have to use this extension point, and you would have to define all of these fields. This is the class of the YAML model, so the class used for defining the model. Then you would have to specify the icon of the model and the class of the configuration dialog. Now, after you do all of this, Epsilon is able to recognize YAML models. And in this configuration, you would be able to see the new type of model. In this case, it's a YAML document with the icon that I specified previously in here. Now I am going to go through a set of methods from the iModel interface that you have to implement. The first method is the load method. In the load method, you have to load the model in memory from storage. And you also have to store various properties that have been selected in the configuration dialog. In the load method, the first parameter is a string properties, and this holds the various properties that have been selected in the configuration dialog. For example, store and disposal, the name of the model, the type of the model, read and load, and so on and so forth. So you would fetch the values from this structure and pass it along to some variables to hold it in memory. And you would also get the file location of the model, right? You could see in here that it fetches the file path, and if the file path is not empty, it creates a new file with that specified file path, and later on it will load the model located at that location. And this happens in the load method. Now, there is also a method called load model. It loads in memory the selected model from the configuration dialog. And it ideally should set up a data structure that keeps track of instantiated model elements. So in the load method, if the property read on load has been selected in the configuration dialog, remember this comes from here. Depending on its property, you could execute different business logic. You could take the value of this property into account. You could not take it. It's your choice. So if read on load is true, if the file is not empty, it creates a YAML content object. This represents the content of a YAML document. So it fetches the entire content from the specified file, and it populates an object called YAML content with the content of the YAML document. And at this point, you have the in-memory representation of your model in memory. But it's a YAML model right now. It could be an XML model, an EMF model. And you also have to set up, or ideally you should set up, a data structure that keeps track of instantiated model elements. It's just a list most of the times. I called it created nodes. And in here, all the YAML nodes that have been created throughout the execution of programs will be stored in this list. Now, to show some code, so this is the load method, the one that I presented earlier, which again calls the load method. This method comes from the superclass in cached model. It clears the cache, then it calls load model, and that will call this method, which loads the content of the model in memory, in this case in the object YAML content. Now another method that you have to implement is called dispose model, and the purpose of this method is to execute cleanup code for releasing model resources. Most of the times you would just empty out the content of your object that holds the in-memory representation of your model. So I just set it to null in this case. And you would also clear the data structure or the list that keeps track of all instantiated model elements, which I called created nodes earlier. So I just clear it out. Another method that you have to implement is the store method. And this method persists the in-memory representation of the model to a specified location on storage. This method is executed only when the value of the store on disposal property is true. This comes from the configuration dialog, and depending on whether the user has set this property to true or not, these two methods will be called or not. So there are two store methods. The one has no parameter and the second has a location parameter. The first method checks if the file has been set, and if it's different than null, then it calls the second store method, with the specified location of the file. And this file object has been populated previously in the load method. And the second method that has a parameter executes some utility service that stores the content of the in-memory representation of the model to the specified file. So you can think of it as a service that takes the content of the model that has been stored in memory and saves it on disk. And these methods are executed only when store and disposal has been set to true. Now, another method that has to be implemented is loaded, and it must return true if the model has been loaded in memory. In this case, if the object YAML content is different than null, then is loaded is true. Another method that you have to implement is model element, and it returns true if an instance is a model element. The way we do this is usually by comparing the type of the instance with the type of the model element. Of course, you could do it in another way, but most drivers do it this way. So the method has a parameter called instance, and you would just check if that instance is an instance of the specified model element type. Remember, when defining your model class with the cached model class, by extending the cached model class, you would also specify the model element type. You would parameterize the class with the model element type. In this case, you would just check if the instance is of type of the specified model element type. Another concept that you have to understand is about types and kinds. Now, to understand this, first I will explain how the YAML driver is implemented. So in YAML, there are three types of nodes. There are scalar nodes, which have a single value. There are mapping nodes, and they look like a map. And there are list nodes. The difference between a scalar node and a list node is that a scalar node just has a key and a value, and a list node has a key and a list of values. And whenever you're working with a YAML driver in Epsilon programs, for example in EOL, you would be querying model elements from within the YAML document. And to query elements from the YAML document, you would specify the name of a node or the key of a node, and in this case it is role, and you would also specify the type of node, because there are three types of nodes in YAML. There are three types of prefixes. S is used for querying scalar nodes, M is used for querying mapping nodes, and L is used for querying list nodes. And the prefix is followed by an underscore and then the name of a node. And in this case, S underscore role would be querying for YAML nodes of type scalar node named role. In the second case, you would be querying for mapping nodes with the name address. And this part, S underscore role, M underscore address, L underscore industry, is actually a type or a kind, and the rest is not important. So it's just this part, S underscore role. And using this type or kind, you would be querying various model elements from your model. And the type of relationship appears when a model element is an instance of a type, and the kind of relationship appears when the model element is an instance of a type or any of its subtypes. Now, just to show some code, so here we have a YAML model, and in here we are querying some model elements. We are searching for a list node named industry, so it would be this node, and then it retrieves all such nodes, and out of all the nodes it just gets the first one. Then it gets the name of that node and it prints it. And it will print industry because this is the name of the node. So this part is actually a type that will be used for querying model elements. The method getTypeOf returns the fully qualified name of the type of a model element. From now on in the presentation, many words will be colored in blue, and they will be referring to various parameters of methods. In this case, instance is referring to the instance parameter from the getTypeOf method. Now, if we look at this method, we can see that we have a parameter instance, and the returned value or object is the class of the instance. And this type represents the class of the model element. Now, if you have chosen to create the model class by extending the class cached model, remember that you would have to parameterize this class by a model element type. And if you have done it like that, so if you have parameterized the cached model class with a model element type, the returned object from this method would just be the class that you have specified in here. Another method that you have to implement is getTypeNameOf, and it returns the type name of a model element instance. Instance is referring to the parameter instance, and the returned string from this method is used for caching purposes. Now, this is the typical way of implementing this method. Most of the drivers do it this way. You could do it in another way. This is the method that was used in the XML driver. And if we look at the code, we can see that it checks whether the instance is an instance of element. Now, element is the model element type in XML. So element represents a model element in XML. So it just checks if the instance is actually a model element. And if that is true, it returns T underscore and the tag name of the model element. Now what this means is that it returns the equivalent type of the model element. So from a model element, it would return something like this, s underscore row, m underscore address. Now for the XML driver, we have t underscore, which refers to tags, and then followed by the tag name. And if the instance is not a model element, so in the else branch, it returns the name of the class. Another method that you have to implement is called getAllTypeNamesOf, and this returns an immutable set over the type name of a single model element instance. Again, instance is referring to this parameter, so it would return a value from getTypeNameOfInstance, which actually calls this method getTypeNameOf, and this returns a string, so it's either the class name if we are in the else branch, or a type, t underscore and a tag name, or something that looks like this, and s underscore row, m underscore address, or it really depends on how you have implemented types. So it would return the type name of this instance, and then it would put that type name into an immutable set, which is a collection singleton. Another method that you have to implement is getCacheKey for type, and the return string is usually the type. If you look at the code, it has a parameter type and it just returns the type. This is the typical way to do it. It's not mandatory that you do it this way. You could do it however you like, but this is how most of the drivers implement this method. The returned value is used as a key for caching model elements by this type. And this is done in the superclasses. You don't do this caching yourself. The hasType method returns true if the model supports a type with a specified name. Now, type from here is referring to the parameter type from the hasType method. And a type, if you remember, looks like this. Well, it really depends on how you implement the types, but in many of the drivers, a type is specified using a prefix and a name. And the first method, the hasType method, has been used in the XML driver, and you could see in here that it returns true if the element type equals the type parameter, or the plain XML type when parsing the type is different than null. And in the YAML driver, it parses the type, and if it returns an object, so if the result is not null, then it returns true. The idea is that you would have to parse the type parameter, and if it has the format that you would expect, then you should typically return true. Of course, in this case, for example, s_row. So you could check if it starts with the s prefix, but you could also search for the row name. You could search in your model for row, and if you find it, you could return true. This method could return true, and if you don't find it, you could return false. But most of the times we don't do that. We just check a prefix or something like that. We just check if the string has the expected format, and if that is so, then you would return true. Another method that you have to implement is instantiable, and it returns true if instances of the type from the parameter can be created. So this type refers to the parameter, and this method is usually based on the hasType method. Most of the drivers do it this way. So you would just check if the type, if the model has the specified type. So you would just call this method, and that would be about it most of the times. Of course, you could do it differently, but this is how most drivers do it. Until now, I've presented methods related to the type of model elements, and now I will go through methods related to creating and deleting model instances. And in this slide, I present some methods that you have to implement for creating model instances. So in these methods, you would create a new model element instance of a specific type and return it. And if we look here, there are two methods for creating model instances. The first method, create instance in model, takes as a parameter a string type, and that's it. And the second method takes as a parameter the string type and a collection of parameters. In the first method, you would have this method called when you would create something without parameters, just with the type. So if you would create a mapping node like this, new mapping node without any parameter, the type would be mapping node, and you would have no additional parameters, and this method would be called. But if you would create an instance of mapping node, which takes additional parameters, like in here in the constructor, it has a city string and Berlin, and these two strings would be passed as parameters in the second object, in the parameters object. And if you would call this line of code, then this create instance method would be called, not the first one, because the first one doesn't have any parameters variable. And the first method typically just calls the second method with an empty collection. If you look in here, it calls the create instance method with the specified type and an empty collection. And it would just call the second method, and then it would create a new model element. In this case, this is the code from the YAML driver, and a model element in the YAML driver is an entry, so it's a key value pair. You would just need to create a model element by using the type and the parameters. So in here you could use whatever service you like depending on your modeling technology. If you would be working with XML, for example, you would create an XML element with the specified XML tag name, and the parameters could be some attributes of that node, and so on and so forth. And again, this entry, so this model element type, comes from here. When you have extended the class cached model with a parameterized type, the model element type that you have used in here would also be specified in here. It would also be the return type of the method. And typically, most drivers also create a list. Remember, there is a list that keeps track of all created model elements, and you would also add the created instance in that list. Created nodes add the new node that has been created. I will go back a little bit to show this. This has been created in the load model method. Remember, ideally, the load model method should set up a data structure that keeps track of instantiated model elements. So in the case of the YAML driver, this is a list called created nodes. And whenever you actually create an instance of a model element, you would add it in here just to keep track of it. And if we can create instances, of course, we also have to be able to delete instances. So you would like to delete the model element instance from the in-memory representation of the model. And you would have to implement the method delete element in model, and it returns a boolean. You would return true if an instance has been successfully been deleted from the model, from the in-memory representation of the model. And I think this code comes from, it's from the XML driver. So it would just go through the in-memory representation of an XML model. It would search for the instance object, and if that is found, it would be deleted, and then you would return true. And also, you would have to remove it from the list of created nodes. Remember the previous list? So you would add new created instances, but you would also remove created instances from that data structure. So just to summarize, you would just delete the instance from the in-memory representation of your model, if it exists in the in-memory representation of your model, and then you would return true. If you could see in the second line of code that it returns false. So if the instance is not even a model element, in this case, if it's not an instance of element, you are sure that instance is not a model element. So of course, you can't find it in the model. You can't find it in the in-memory representation of the model. So there's no point in continuing. You would just return false. The owns method returns true if the model element instance, and instance is referring to the parameter, is contained within the in-memory representation of the model or in the list of created instances. So if this instance is contained within the in-memory representation of the model, we would just return true, and if it's not, we would return false. If we look at the code, it first checks that the instance object is an instance of element, meaning that the instance object is a model element. And if that's true, we will execute some other business logic. And if that's false, we would just return false, because if it's not an instance of element, then it's not a model element. So there's no point in searching the model if it contains that model element, because it's not a model element in the first place. Now in this branch, It first checks that the created elements list contains the instance object. Remember, the created elements list is referring to the created nodes or the data structure that keeps track of all created instances. And if it contains it, it returns true. And otherwise, it also checks the in-memory representation of the model in this else branch. And if it finds it, then it returns true. Another method that you have to implement is all contents from model, and this method returns the entire content of the model, meaning all model elements from the model. Now, here we have two examples of implementations. In the first example, we have a list of rows. This has been used in the CSV driver. So in the case of the CSV driver, the in-memory representation of the model is represented using a list. And in this case, it is much simpler to work with a list because in this method, all contents from model, you have to return a collection or a list. And in this case, you could just return this in-memory representation of the model, which is just a list. So it just returns rows. You don't have to do any processing. But in the case of the XML driver or in the YAML driver, you don't have a list. In the XML driver, we have a document object, and in the YAML driver, we just have an object. And in that case, in this method, all contents from model, you would need to call a method that collects all model elements from within your model object. Here in the second line of code, we have collect all elements that goes in the document object, and this object represents the in-memory representation of your XML model, and then it fetches all model elements and adds them to this elements list that has been created in the first line of code. Then it also iterates through all created elements, so the data structure that keeps track of all instantiated model elements, and it also adds these elements to the list of elements that will be returned. And then it just returns this list of elements that has been created and populated with all model elements and all instantiated model elements. The method getAllOfType from model returns all model elements with the specified type. So it's similar to this method, just that it filters model element by a specific type. In this case, it takes as a parameter a string type, and in the XML driver, that type is parsed, and the result is an object of plain XML type. And this object, plain XML type, has various methods that can be executed on it, like getTagName. So from a string type, you would be able to extract the tag name, and we would have a new string variable called tag name. And then the code creates a new list, AllOfType, that would contain all model elements with this specific type. And then it goes through the entire content of the model, and it iterates through all model elements. And if a model element has the same tag as this tag name, or the tag name contained in this type, it would add that element to the list that will be returned, that will contain all model elements of this specific type. So normally you would parse this string with some business logic, and you would extract some information from it. Like in this case, it extracts the tag name, and then you would filter out the entire content of your model using that tag name or that information that you have extracted. It could as well be just the type, so you may not need additional processing on the type. Like in this case, it first parses the type to a plain XML type, and then from that object, it extracts the tag name, and then using the tag name, it filters out model elements. there is one more method called getAllOfKind from model, and this method returns all model elements with a specific kind. In many cases, the kind may be similar to the type. Therefore, the method can just call getAllOfType from model with the kind parameter. So it would just call this previous method because the kind may be similar to the type. Remember, types and kinds. The type of relationship appears when a model element is an instance of a type, and the kind of relationship appears when a model element is an instance of a type or any of its subtypes. So depending on your modeling language, you may or may not differentiate between kinds and types. In this case, in the case of the YAML driver or in the case of the XML driver, a kind is a type, so there is no difference between them. And in that case, it just returns the output of the getAllOfType from model method, so the previous method, by taking the kind parameter. So this kind parameter would be passed in this method as a type. To get a better understanding of these methods, now I will do some small exercises. First, I will modify the method getAllOfType from model, and then I will also modify the methods used for creating and deleting model instances. So the first method that I'm going to modify is getAllOfType from model, and as of now, it's returning all YAML model elements from a YAML model that are of this type. And of course, this is the model class that was used in the YAML driver. And what I'm going to do is change this method by adding these lines of code. I've added an entry that has the key country and value Germany, another entry with a key city and value Berlin, and this method now returns a list of two entries, the ones that I just mentioned. So what's going to happen now is that instead of returning YAML model elements of this type, I am always going to return these two entries. So to test this out, I have to run a new Eclipse instance. This is my YAML document, and this is an EOL script. Normally, this line of code would have searched for scalar nodes because it is prefixed with S, and scalar nodes with the key role or the name role. And normally, it would have returned this YAML node. But now, regardless of what I'm going to type in here, I will always get as a result these two entries that I've mentioned in here. So when I execute this script, this method will be called. Right now I'm in debug mode. And you can see that the output is a list or a sequence that contains the two entries that I've specified in here. Now, if I modify this type, this is the type that gets passed in as a parameter in this method. In this method in here, this type is not taken into account right now, because if you look at the code in this method, the type is not used anymore. It was used previously here, but right now it's not used anymore. So regardless of what I'm going to type in here, I'm always going to get the same output because the type is not taken into account. So this is the type that I've just written in the EOL script, but it's not taken into account right now. I just create two entries, add them to a list, and return the list, and that's it. So what I'm going to do now is to modify this behavior, because right now I'm just returning a list of entries, and that list of entries is always the same regardless of the type. So to modify this behavior, I will delete these lines of code, go back to the previous implementation. I'm going to create a new variable that holds the model in memory. So you could think of it as the in-memory representation of the model. We already have an object that does that. So the object YAML content already stores the YAML model in memory. But I will create an additional variable that does that, and it is of type list, and it contains a list of entries. You could think of it as a list that will hold all the model elements from a YAML model. And right now it's empty, so I have to populate this list with model elements, and you would usually do this in the load model method. In the load model method, we already have a line of code that populates the object YAML content with the content of the YAML document. So you would typically do that in here. I will just populate it with some fake values. So you could think of these entries as your hypothetical YAML model. It would be a YAML document or a YAML model that contains 4 entries, and each of the entries is a model element. It would just be a YAML document that looks like this. So all of these entries would just be added to a YAML document instead, and then you would retrieve those values and add them yourself into this list. But right now I do all of this by hand. I do this in a hard-coded manner. I create the entries manually and I add them to the list. So right now the model variable will represent the model in memory, and it contains a list of all model elements of the model. And right now it contains 4 entries. And the next step is to use this in-memory representation of the model in the previous method that I've modified. This method, get all of type from model. So instead of using the previous code, I am going to use this code. So what I'm doing in here is that I create a new list of entries, and this will be the model elements that will be returned by this method. And all of these model elements will be of this type, the type from the parameter. And then I go through all the entries from the model, so the variable that I've just created that stores the model in memory. So it's this one that contains these 4 entries that I've just added. And then I go through all of those entries, and if the key of the entry is equal to the type, then I add that entry to the list of entries that I will be returning from this method. Now, to test this out, I have to launch a new Eclipse instance. I will run this EOL script, and now this method will be called. The type is sRoll, and this comes from here. And now it will go through all the entries from my model, which are the ones that I've added in the load model method. So in here, it will go through all of these entries and check if the key is equal to the type. And if it is equal, then that entry will be returned by this method. And of course, none of the entries from the model have as key the type that I've entered. So the type is sRoll, and none of these entries have that key. We have as key continent, country, city, and city. So none of them are equal to s_roll. So it will return an empty list. And now what I can do is I can modify this type to something that exists in that model. So I will use the type country, and this exists as a key in this model variable, and it should return this entry right now. And it seems that it's not working, and the reason for this is that the method has type does not allow it. So has type will check if a type is valid or not. So it will check if this type, country, is a valid type or not. I will put a breakpoint in here and run the script again. Okay, so this method has been executed. And again, what this method does is it checks the type. So the type is country, and it verifies if it is a valid type. And usually to do this, it just parses this string type, and by using some business logic, it has to determine whether it's valid or not. Now, since this is the YAML driver, this won't be valid because the YAML driver must have the types prefixed by S, M, or L. Because in YAML there are three types of nodes: scalar nodes, and those are prefixed with S; mapping nodes, and those are prefixed with M; and list nodes, and those are prefixed with L. And if you don't have any of these prefixes, of course, the type is not valid. So this is why this won't work, because it will first go into this method, and has type will say that this type is invalid, and it will return false because it's invalid. And then this method won't be called anymore because you already know that the type is invalid, and there is no point in continuing. Okay, so what we must do now is modify this method such that it will allow types that do not have prefixes. And just for the sake of simplicity, I will just return true, and that's it. This method will always return true, so the type is always valid. It doesn't really matter what type you're using, it will be valid. Of course, in your EMC driver, you have to use some kind of business logic, you have to do some kind of parsing, and by parsing the type, you have to determine if your type is valid or not. Because the point of this is that you don't want to execute other methods since you already know that the type is invalid, because there's no point. Okay, so now I've modified the method, and I will launch again a new Eclipse instance. So now it goes in the method has type and it returns true. And then it goes in this method get all of type from model, and the type is country. And now in this model it will search for an entry that has the key country because the type is also country, and it has found an entry, so the entry has the key country and value Germany, and it will add that entry to this list of entries, and then this list of entries will be returned. And we can see the output in here. So we have a list that contains the entry with the key specified by this type. So if I will change this right now to continent, what it will do is to return this entry from the model. Right. It returned this entry. Now I also have to modify the method for creating instances. So I am going to modify the method create instance. Right now what it does is that it creates a new node, a YAML node, and this is of type entry. And to create this, it uses a service, an utility service, and the method get node. And this method takes into account the type of node and the parameters of the node. Once the node is created, it is added to the list of created nodes. If you remember, I said that it is recommended to use a data structure that keeps track of all model elements, of all created model elements. And this is that structure, it's a list, and then the method returns the created node. Now I will modify this behavior. And this variable hasn't been declared yet, so I will go now and declare it. It's a list. So what I do now is to get the first parameter. So from this parameter of this method, I get the first string, then I get the second string, which represents the second parameter. Then I create an entry, and this has as key the first parameter and as value the second parameter. Then this would represent the new instance. So this is the new model element that has been created by this method. And then I add it to the list that I've just defined. So created model elements. This is the data structure that keeps track of all instantiated model elements. And then I return the created instance. So to test this out, I have to run a new Eclipse instance. This method gets called whenever I create a new object, so whenever I use the new operator. So in here, I create a new model element. I call the type model element. This is the type of the instance. You could call it however you like. It really doesn't matter. And this takes two parameters. This represents the type, and these two parameters from the constructor represent this object. They will be passed into this object. Now I've executed the script, and you can see in here in debug mode that the type is model element and the parameters are city and Berlin, because these are the parameters that I passed into the constructor. Then it gets the first parameter, city, then the second parameter, Berlin, then it creates an entry which represents the new instance or the new model element. Then I add this object to the list of created model elements that keeps track of all created model elements, and then I just return the newly created instance. And that's about it. So this is what you have to do in the create instance method. You have to take into account the type that has been passed in here. This is the type, and the parameters that has been passed in the constructor. You can have no parameters. You can do it like this. And of course, you could put any name in here. The type would be www. And then using this type and the parameters, you would have to use some kind of business logic to create an instance of a model element that takes into account the type and the parameters. Then you would add that created instance to a data structure that keeps track of all created instances. This is not mandatory, but it's recommended. And then you would return the created instance. And really, that would be about it for creating instances. And the next thing that you would have to do is also delete instances. And for that, you would have to modify the method delete element in model. What this method does right now is that it takes as a parameter an instance or a model element, and then it just searches the model for that instance, and if it finds it, it deletes it. If it deletes it, then it returns true. If it doesn't find it and it doesn't delete it, it returns false. So I'm going to modify this behavior. So what you would do is you would have a parameter instance. This is something that comes from the signature of the method. Then you would remove the instance from the model or from the in-memory representation of the model. In this case, if you remember, this is the list that I've initialized with all of these entries. So you would remove that from the model, but you would also have to remove it from the list of created model elements. So the data structure that keeps track of all created model elements, if you have chosen to use one, because this is not mandatory. You don't really have to use it, but it's recommended. And if this lines of code executed successfully, so if you have deleted either from the model or from the created model elements the instance, then it should return true. And really, this is about it. This is what you would typically have to do when deleting model instances. And this method would be called whenever you would execute something like this, delete. This would get the country element, then it would get all country elements, and out of all of them, it would just get the first one. And then it would delete that, the first country element. And when you use the delete operator followed by a model element, then this method would be called and it would search that instance in the in-memory representation of the model. If it finds it, it deletes it, and then you would also delete it from the list of created model elements if you have one, because as I said, this is not really mandatory. And really, that's about it. Now I'm going to present some other methods that you can implement, and they are not mandatory. getElementById is used to return a model element by its ID. So what it does is that it iterates all model elements from within the model, and then it finds a model element with the specified ID and it returns it. Now we have here some examples. For CSV, you could think of IDs as a specific column. Well, you could do it in another way, but this is an example. So a column from the CSV could be used for identifying the ID of a model element, and each row would have the ID at that specified column. Also in XML, in XML elements, you could have as IDs an attribute of the XML element. So you could have an attribute called ID, and that could be used for setting the ID of an XML model element. Of course, you could do it in a different way, but this is just an example. Here we have an implementation of the getElementById method. This has been used in the plain XML driver. And what it does is that it goes through the entire content of the model. So it iterates through each model element. Then for each model element, it checks if it has the attribute with the name ID attribute name. This could be any name. Most commonly, it may be called ID. And then if it has that attribute, then it gets that attribute. And if the value of that attribute is equal to the ID, which has been specified in the parameters, then you would return that element, because that element would have the ID attribute equal to the ID parameter. And if you don't find any model element with that ID, you would just return null. There are other methods related to IDs like getElementId and setElementId. They get or set the ID of a model element. Here we have an example of implementation for the getElementId method. It takes as a parameter an instance, so a model element, and if that element has the attribute ID attribute name. So for example, you could think of an XML attribute, an XML element, and if that XML element has an attribute called ID or something similar, you would just get the value of that element, or you could set it. In this case, it retrieves it, but in the case of setElementId, you would change the value of that attribute. There is also another method, getEnumerationValue, that adds support for enumerations. This is not commonly used, but it's good to know that there is support for enumerations, but you have to implement this yourself, of course. A driver that implements this method is the EMF driver, so you could check that. And this is used to retrieve an enumeration literal from a specific enumeration. For the implementation of an EMC driver, 3 classes are required. A class for defining the model, and I have already covered this. A property getter class for the model, and a property setter class for the model. The property getter class must implement the iPropertyGetter interface, and the property setter class must implement the iPropertySetter interface. In here, we have the constructor of the model that was used in the YAML driver, and we can see that 2 variables are set up, one for the property getter and one for the property setter, and they instantiate the class that was used for the property getter and the property setter, and they take as a parameter in the constructor this, which refers to the current instance of the YAML model or the model class. This is the class that I was referring to. This is the YAML model, and it extends cached model. In the constructor, the 2 variables are set up. property getter and property setter, but they have not been defined in this class. They have been defined in one of the superclasses. So it extends cached model, but cached model did not declare these variables. Cached model extends model. So if I go in the model class, you could see that the model class has defined these two properties, the property getter and property setter, and it has instantiated this object with these classes. And if you extend model, or if you extend cached model in your model class, then of course you would get these variables built in because you would be inheriting them. But if you choose not to extend cached model or model, then you would implement directly this interface, the iModel interface. And in this interface, there are two methods, get property getter and get property setter. And you would have to implement these methods yourself, and each of them would have to return the variables that you would define yourself. So you would define yourself the property getter, the property setter, and you would return them in the implementation of these methods. The model class already does this. So if you extend the model class or the cached model class, you would get this behavior by inheritance. But if you choose to not extend these classes and implement the iModel interface, you would have to implement everything yourself. For defining the property getter class, you could either implement the iPropertyGetter interface or extend one of the following: the abstract property getter or Java property getter class. These are links, and if you'd like to look at the code, you could just click on these links. This class is used for retrieving the value of a property from within the model or within a model element. Here, there are some examples of implementations of property getter classes. You have an example from the CSV driver, from the plain XML driver, and from the YAML driver. You can check this out. For implementing the property getter class, you have to implement one method, and that method is invoke, which takes three parameters. One is an object, one is a property, and one is the context. And if you would execute this, let's say you would execute this in EOL, this is used for the YAML driver. And remember that in YAML there are three types of nodes: scalar nodes, mapping nodes, and list nodes. And the way the YAML driver is implemented is that it specifies S underscore if you're searching for scalar nodes, M underscore if you're searching for mapping nodes, and L underscore if you're searching for list nodes, followed by the name of the node. So in this case, it would search for scalar nodes named employee ID, and it would return all of them. And then it would just get the first one. And the resulting object from this orange part would be passed into this parameter, into the object parameter. So the object that would be resulted from this part would be passed into this parameter, and then you would have dot value, and value represents a property of this object, and the value string would be passed in the property parameter. And in this method, typically you would check the name of the property, which in this case is value, and you would execute different business logic depending on the property. For example, if in this case, if the property ends with value, so if the property is value, maybe you would execute different logic than when the property is name. So depending on your property, you would execute something else. You would use some kind of different business logic to retrieve the value of that property from this object. So from this object, if you look in here, it returns a value, and this takes into account the object. So this object, YAML content, this YAML content variable has been created using this object from the parameter, and taking it into account the object and the property, then it retrieves a value or an object, and then it returns that object. So again, in this method, you would get as a parameter an object and a property, and depending on the property, you would execute various business logic on your object, and you would extract data from your object and return it as an object. For the property setter class, instead of getting the value of a property, you would set the value of a property from within the model, and it can implement the iPropertySetter interface or extend one of these classes, abstract property setter, Java property setter. Here there are some examples of implementations of property setter classes, and one is from the CSV driver, plain XML driver, and YAML driver. So check this out. And the method that you have to implement in this case is invoke as previously, but the difference is that there is one additional parameter which is called value, and this is the new value that you would set to that property. So the first parameter object is referring to this part, to the orange part. This would represent an object or a model element from your model. Then dot value, this represents the property that you would like to change the value of. Then you would have an assignment operator followed by the value, the new value that you would like to assign to this property. And in this case, first the property is checked, because maybe if you would have different properties, you would set the value of that property in different ways. So you would use different business logic depending on your property. So if the property is value, then you would set the value of your object with that value, this value, which in this case is Jack. So you would set the property called value to Jack, and then when you would retrieve the value of this property, when you would retrieve the value of the value property, you should also get Jack. So in this class, you have to implement this method, which specifies how to set up the values of properties of model elements. To understand better how these classes work, I will do some exercises. First, I will add a new property in the property getter class, and then I will add a new property in the property setter class. This is the YAML driver. This is the YAML property getter. So this is used for setting properties in YAML models. The class extends Java property getter, and it implements the invoke method. Right now, this method can work with several properties like the value property, the name property, and the type property. And I will add support for a new property called metadata. So if the property is equal to metadata, I will return this string executed today on entry, and it will take the object and then the key of the object, and then it will concatenate all of this and return this string. To test this behavior, I have to launch a new Eclipse instance. This is the YAML document, and I will execute this EOL script. So what it does is that it gets the scalar node named role, which is this one, and then from the document it takes all scalar nodes named role, and then it just retrieves the first one in this variable model element, and then I print this model element, and then I also print the metadata property of this model element. Now I'm in debug mode, so if I look at the object, you could see that it's an entry with the key role and value consultant. And if I go in the YAML document, you could see that it's this entry. The property is metadata, this one. And then when executing this method, it gets to this point and it checks if the property is equal to metadata, which it is, and it returns this string. Executed today on entry row. And really, that's about it. Now I will continue with the second part. Adding a new property in the property setter. This is the class used in the YAML driver for setting the properties of YAML models, and it extends abstract property setter. It implements the invoke method, and right now it is able to work only with the property value, so you're just setting the value of model elements. But of course you could add support for any value. In this case, I will add a new property called metadata. So I will just add a new else if branch, else if metadata is equal to the name of the property. Then I will set the value of the object to the value that has been passed as a parameter. To test this behavior, I have to launch a new Eclipse instance. What this script does is that it takes all scalar nodes with the name role. This is the only one. And then it gets the first one, and it holds the result in this variable model element, and then it prints this model element, which is this entry, and then it sets the value of the property called metadata to this string, metadata about this model element, and then it prints again this model element. And let's see what happens. Now I'm in debug mode. The object is this entry, role consultant. So this entry. The property is metadata. This comes from here. And the value is metadata about this model element. And this comes from here. Now, else if metadata is equal to the property, which is true, it will set the value of this object. So this entry, it will set this value of the role consultant entry to the value that has been passed as a parameter, metadata about this model element. So now object will be an entry with the key role and this value. If I look at the YAML document, you could see that it has also been saved in here. So it has the key role and the value has been changed. the metadata about this model element, and it has been printed out again. First, it printed out the previous value, then it changed the value, and then it printed out the new value. And really, this is about it. When setting properties in the invoke method, you would have to have some kind of business logic to set the value of a property of an object, depending on the value that you have used. So depending on this property, and depending on the object that you're working it, you would set some properties for that model element, considering the assigned value. It doesn't really have to be this value. You could do some concatenations or something like that. To summarize this session, for implementing an EMC driver, you have to implement two plugins. The first plugin represents the implementation of the driver's Eclipse-based development tools, and this is used for creating a dialog in which the user can select the model that he would like to work with, and also various properties of the model. Then you would have to implement a plugin for the EMC driver itself, and this contains the actual business logic of your EMC driver. And in this plugin, you would fetch the various properties that have been selected in the dialog, and depending on those properties, you may execute different business logic. Of course, you can choose to not take those properties into account. Technically, to implement an EMC driver, you need three classes: a class for defining the model, a property getter class for the model, and a property setter class for the model. The class for defining the model is used to represent the model in memory. The property getter class is used for retrieving various properties from your model, and the property setter class is used for setting properties from your model.